In this video, we'll discuss about statistics, the role of statistics in machine learning. It's having two parts. In part 1, we will discuss about some of the theorems and the descriptive statistics. In the second part, we will learn about the inferential statistics. So the agenda will, in the introduction to statistics, central limit theorem, descriptive statistics. In the part 2, we'll take the statistical hypothesis tests and the inferential statistics, and how the statistics is used in various stages of the machine learning. It's a field of mathematics that is universally agreed to be a prerequisite for deeper understanding of machine learning. So there is a connection between the statisticians, software developer and ML practitioner. The common terms which will occur in this video: the observation. Observation is actually a result of a trial of an experiment. Population is the space of all possible observations, and sample is a group of results gathered from separate independent trials, and it's a part or a snapshot from a broader population of all possible observations. Many observations fit a common pattern or distribution called the normal distribution or the Gaussian distribution. Central limit theorem. It describes the shape of the distribution of the sample means as a Gaussian, which is a distribution that the statistics will tell about the mean and the standard deviation. As the size of the sample increases, the distribution of the mean across multiple samples will approximate a Gaussian distribution. It will be more accurate if the size of the sample drawn is increased, regardless of the parent population distribution. Here 8 types of parent population distribution has been shown. The straight, the slanted one, some irregular shape is also there. The 5th one is a normal Gaussian, and the 6th, 7th is one skewed normal Gaussian distribution, and there's a slope in the 8th. So the mean of the population of the means is always equal to the mean of the parent population from which the population samples are drawn. And the standard deviation is always equal to the standard deviation of the parent population divided by the square root of the sample size. The distribution of means will increasingly distribution as the size n of sample increases. What is this implication of the central limit theorem on the machine learning? In machine learning models used for predictive modeling, so when we want to learn, we should have enough samples. So how to know whether the model is doing good or not, given the accuracy of X% or error score of Y? The CLT or the central limit theorem will be used to answer this question. There is a baseline model, scores and performance, which is used against the other models for evaluation. For a unique problem, the data is stochastic and hence we have a predictive model. This is a central limit theorem demonstration. The central limit theorem demonstration is on the characteristics of the population of the means, which has been created from the infinite number of random population samples, and they are drawn from the parent population. The diagram here is that of the parent population with 8 options given, and if we click on the first one, if we draw that, then the population, the shape takes that of the parent population. If we do the number 2 with the sample size of 1, the histogram shape is that same as that of the parent population. Say number 6, if we draw, this is of the same population distribution. 8, if we draw here, you see, it will be mimicking the same shape as that of the parent population. And this also shows 2 more data, which is mean and the standard deviation of this distribution.
If we see here, mean is now here 24.3 and the standard deviation is 21 point. The population size, here are three options are given: a small population size, medium population size and a high population size. If we see small population size, taking one sample and draw, the same shape is being generated, that of the parent population, and the mean is 24 and the standard deviation is 21.6, which is more or less same. Let us take a population size of high and the shape will take the same shape as that of the parent population. Mean is 24 and standard deviation is 21.5, which is more or less the same. Now let us take the population size, choose medium, and here the sample size, we can increase the sample size by pressing the button INC, increment, and if you want to decrease, you can use DEC. So let us increase the sample size to 3. Okay, let us have the sample size as 5. And now here in the left hand side, we will see the central limit theorem, the three characteristics. Make a note, the mean of the population, parent population is 24.3 here. So the mean of the population now, if we draw, it is now 24.3. So it is same. So the first characteristic, the mean of the population, the means is always equal to the mean of parent population from which the population samples are drawn. Now coming to the standard deviation. The standard deviation of the population of means here is equal to the standard deviation of parent population. Remember, it was 21.7 divided by the square root of the sample size. What is the sample size here? 5. So 21.7 divided by the square root of 5, which will give you 9.7. So that is the third characteristic. So what is the first? Mean remains same. Standard deviation is equal to the standard deviation of the parent divided by the square root of the sample size. And the third one, if you see the very impressive part, it says that the normal distribution, the histogram takes the approximate distribution, that of the Gaussian or the normal distribution, or also it is called bell curve, bell shaped curve. And here, even if you increase the sample size to 30, maximum it can go to 30. Again, if we draw, see, it is now approximated to the bell curve. So even if you take any parent population and increase the size of the sample, and now you will see the third characteristic, it has taken that of the.
Then coming to the law of large numbers, as the size of the sample is increased, the more accurate of an estimate the sample mean of the population mean. Collecting more data will lead to a more representative sample of observations from the domain. That's what we could see it from the demonstration as well. So the demonstration showed the central limit theorem as well as the law of large numbers. And the central limit theorem does not state anything about a single sample mean. Instead, it is a broader and states something about the shape or the distribution of the sample means. So whether we have taken the parent population of 1 or 8, 2 or 4, the distribution always took the shape that of the Gaussian. That is the central limit theorem. Regardless of the distribution of the parent population, the mean is always equal to the mean of parent population, and standard deviation of the population is always equal to the standard deviation. So implications of the central limit theorem on the machine and the law of large numbers in the machine learning: training data, test data, and model skill evaluation. In the training data, to train the model, we need a true representative of the observations from the domain data set. To have a true representative, the number of samples should be more and should also be of unbiased data which are taken as samples. In the test data, again, it is often neglected that the 80-20 splits for the train and the test data are used, but if we use with 10-fold cross validation, then the training also would be more appropriate and the test accuracy will increase. In the model skill evaluation, it highlights the need to develop a sample of multiple independent evaluations of a given model so that the mean reported skill from the sample is an accurate one. The statistical tools and methods, it's having the differential statistics, descriptive statistics, statistical tool and methods. The statistics, two types: descriptive statistics, inferential statistics. Descriptive statistics, the measures of central tendency and measures of variability. Two measures are very important. In inferential statistics, we draw inference of the population from a random selected sample. In this diagram, there are three curves: green, blue and the red. The red mean is equal to 2, which is at the peak. The standard deviation is 0.5. For the blue, the mean is equal to 0 and the standard deviation is 1. And the green, mean is equal to -2 and the standard deviation is 2. Two metrics used is the central tendency matrix, which is the mean, and the deviation matrix, which is called the standard deviation. What is the implication of the standard deviation and mean for a given data set? For example, for an IQ with a mean of 100 and a standard deviation close to 15. So if the IQ is anywhere from 85 to 115, considering one standard deviation of the mean. 130 value for IQ is 2 standard deviation above the mean, which is considered to be genius. For a value of 70 IQ, it is 2 standard deviation below the mean, which causes a concern, and it's also termed as mental retardation. We can see that given any value of IQ, in terms of standard deviation, we capture 68% of the data with 1 standard deviation, 95% of the data in 2 standard deviation, and 99.7% of the data with 3 standard deviation from the mean. Crosses plus or minus 3 standard deviation, it is considered as a outlier. In this quiz, in the first one, we want to comment on the mean and variance for these 3 plots. Are they same or different? Mean, are they same or different for figure 1? For figure 2, are they same or different? For figure 3, are they same or different? Okay, so the blue one is having different means, same standard deviation. The black plot is same mean with different standard deviations, and the third red color plot is having different means and different standard deviation. There are very two important concepts: coefficient of variation and correlation coefficient. Coefficient of variation can be used to compare two data sets to know which data set has a higher spread around the mean. Whereas correlation coefficient, it quantifies the relationship between two variables, whether they are in a positive direction or in a negative direction. Means when one variable's value increases, the others also increases. When one value decreases, the others also decreases. So this is a positive correlation. That is, it changes in the same direction. Negative correlation, the variables change in the opposite direction. With the increase in one, there is a decrease in the other, or decrease in one implies the increase in other. Neutral correlation, there is no relationship between the change of the variables. There are certain measures, certain methods to compute the correlation coefficient. Like example, one of them is Pearson's. In diagram, we can see the negative correlation. The coefficient is called the rho, which is having a value from -1 to +1. For a positive correlation, no correlation and negative correlation rho equal to -1, or it is less than 0. For positive correlation, rho is greater than 0, maximum 1. And when there is no correlation, rho value will be equal to or nearby 0 value. The statistics basic formula, population standard deviation variance formula, then coefficient of variance formula, Pearson's correlation coefficient, how to compute covariance. This is a Python programming for statistics where we can get the mean, variance, standard deviation from NumPy package. So the problem here is showing that it generates 100 numbers from a Gaussian distribution with the mean of 50 and a standard deviation of 5 and calculates the summary statistics. So from NumPy.random we import seed, then NumPy import mean, import variance, VAR and import STD. So create a random number 100 and then calculate and print the mean, variance and the standard deviation. In the quantitative data, the descriptive analysis, have some visualization by using tables, graphs, numbers. When it is a number, then the central tendencies can be computed using mean, as we have discussed. It can be also computed by median, mode, geometric mean, harmonic mean, trimmed mean. One can go through each of these, and depending on the problem statement, the central tendencies are chosen. A point which will be very important for understanding the quartiles, deciles, percentiles. Then there is a variation matrix like range, interquartile range, variance, standard deviation, and to know the distribution, a skewness and kurtosis is used to understand the distribution. In the graphs, the histogram, box, whiskers plot, a lot more are there. The tables, frequency distribution, stem and the leaf plot are there. This is some of the visualization tools like a histogram. The frequency measure of the elements are plotted. Then bar graph, it also represents the frequencies of the respective categories. It can be used for the categorical and the frequencies. There can be stacked bar, side, multiple bars, and the quiz. This is a solution. If the variance value is 0, it means that all the values of the data set are identical. So variance can be seen as a risk indicator of a specific asset. Higher the variance, the greater the investment's volatility, because in such cases prices tend to spread across a bigger range. For answer 3, from a conceptual point of view, the standard deviation will tell us how normal or standard a value can be. The more the value drifts from the mean, the more is its standard deviation. Then coming to the coefficient of variance, it can be used for comparing two data sets with which data set is having more spread. Correlation coefficient, whether the money is related to the state of mind. More money, more happiness, less money, less happiness. So this is a philosophical one, depends from person to person. So what do you think about the value? Thank you.